Hello, hello. Hello. Okay. So, in the last stream, I I guess stopped at squares of a sorted array. I wasn't able to solve this problem on my own. So yesterday actually I was offline. I didn't do it on stream. So off stream I solved this problem. I used nested loops to solve this problem, but this doesn't actually work properly because if I hit submit for this solution, it will take forever to run. If it is a larger array, because if you see the constraints, the maximum value is 10 raised to 4, and the length is also 10 raised to 4. So if array is that big, you will see it is giving time limit exceeded error. So I am not able to submit this solution, but this solution works. I mean, uh, so if here you can see, out of 137, 135 test cases are passed. This particular one is not passed because it has large count of numbers. So I somehow managed to solve it, but not properly. Uh, Once I understand the different sorting algorithms, I would be able to solve this one properly. I have seen the other solutions. They actually use two pointers. So one starting from the left end of the array, and second one starting from the right end of the array, and that's how they sort. uh, but I'm not directly going into it. I need to learn those sorting algorithms, then I will solve it properly. Then inserting items into an array. So in that, this duplicate 0 I was working upon. So here I have it opened, the duplicate zeros problem. For this one also, while offline, I tried to solve this problem. uh, So I took a little bit of hint that in this case we need to go from the go in the reverse way. So the loop should start from here, this position, not from the beginning. So first, how I solved that, I will write it here because I used a notebook to solve it. So let's say our array is like this: 2 3 0 4 0 0 5 0. Okay, so this is our array, and now we want to add one zero after the present. The zero, everywhere zero is present. After, the next value should also be zero. So that is our problem. I will just extend a little bit more, otherwise everything will be 0 0 0. So 1 2 3 4 0 1 2 3 4 5 6 7 8 9. So then if this is ARR, then equal to 10. 9 1 2 3 4 5 6 7 8 9 10. So length is 10, so I guess I will keep it as n equals 10. Then So count of 0, I don't know how to use this, but I will just have it with me. 1, 2, 3, 4. So count of 0 is 4. So if we have to do it manually without using an array, I will just write the steps, then I will apply the loops. So for the first 0, sorry, first 6, I will check if ninth element ARR of 9 equals to 0 or not. Just like this. So here it is not. So here do nothing. Then ARR of 8 equals to 0. In this case it is true. So what I need to do, uh, I need to make ARR of 9 equals to ARR of 8 and ARR of 8 equals to 0. Then 7. For 7, again we will apply check and we will do nothing because it is not a 0. Then 5. 9, 8, 7, 6. So again ARR of 6, do nothing. 0, again we'll check fifth element. It is equal to 0, that's why we will assign 9 equal to 8th value, 8th equal to 7th value. So here what this step we are making space for additional 0. So we are moving the elements from current position to their next position. So we are kind of moving on to the right side. 7 equals to ARR of 6, ARR of 5, sorry, ARR of 6 equal to 5 and ARR of 5 equals to 0. So we have added new element. So here from the fifth position we have moved that 0 to 6, sixth position. From fifth to sixth move, then fifth became empty kind of. I mean it is not actually empty, the original 0 is present, but we are writing the new 0 over there. I guess that this step is unnecessary, right? Okay, we will think about optimization afterwards. For now we'll keep it as it is. Then again one more 0 is there. Equal to ARR of 4, then ARR of 4 equals to 0. Then 10 comes for 4. Here we will do nothing because 4 is not a 0, which is the third element or element at index 3. Then we have 1 0, which is ARR of 2 equals to 0. This is our condition. It is true, so we will move everything. Then for the remaining part, we have to do nothing. So just copy this part. So this is our flow, and we want to write logic for it. So our for loop will go like this. For or while? I guess for loop. For I in range. I need to turn this off or to stop automatically. So the range here will be little different. -1. No. We need to go from and we need to go in reverse order. So our start is 10 and from 10 we are going in reverse. But we don't want 10 because the last index will be 0. So -1. So from 9 we will go in reverse. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Like that we will go. Yes, -1 I doubt. No, this is correct. In range like this. We need to check if I equals not I, if ARR of I equals to 0, in this case if it is 0 I need to perform this activity. So to perform this activity I need to write code. So I have I which will be 9 in the beginning, 8, then 7, then 6, but inside loop I always have to start from 9. That means there will be one more loop, maybe it will be while loop, while some condition is true. While some condition is true, I need to perform swap operation. So what is this some condition? Some condition is while that index is not reaching equals to I. Correct, no? So this index, this is our I. This phi is our I. And then we have one more index inside. So let's say j equals to n, while j not equals to I need to swap. So initially j will be 9 because n is our tens. Okay, sorry, n minus 1 I need to put here. J is n minus 1, so which is 9, while j is not equals to I, while j is not equal to this value, I is over this is over j. We have to iterate or swap until that value reaches to 5, j reaches to 5. So while j is not equal to I, how to write this swap operation? So we have j, we are going to, in the end we will be reducing the value of j minus equals 1, while j not equals to I, arr jth value equals to arr j minus 1, isn't it? This looks fine for me. So if it not equals to I, it will just change the value, and this will run till j is not equal to I. Once it becomes equals, it will do nothing and it will come out of loop. So when it will become equal here at this stage, and like I said earlier, this part was unnecessary because there is 0 present at that position, so we don't have to create a 0 because we are not creating any empty space. So that works. So let's try it out. I know there might be some problems, so we'll test over here. So we have our arr n equals to len of arr count. I'm not checking, we just go for the loop. N minus 1 comma minus 1 comma minus 1. If we just if 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 arr of I equals to 0, so I'm starting checking from the right hand side. If it is 0, then j equals to n minus 1, which is the length or the starting index, and I will apply while loop to swap the values. So the sum condition is our j not equals to I. j minus 1. I'm updating j as well. So they are saying do not return anything, modify ARR in place. So I guess they should do invalid syntax. What's wrong in the syntax? For I in. Yeah, finished. Now check how many test cases this will pass. Pass. Accepted. Wow. So how to interpret this thing? Runtimes 651 ms. That is higher compared to the other 79.08% of solutions. So I need to improve. So time complexity is high, but my code works. I mean, the logic which I have wrote is working. I am happy with that. The reason is I'm able to solve it on my own. Definitely, I haven't studied any sorting algorithms or anything. So I'm happy with the results. So let's check the other solutions. Oh, am I allowed to check or do I need to pay for it? So I need to have the Python solution. So till, till this part, I was right. He has used zeros equals to ARR dot count 0. So he has used this count. I actually went through a solution earlier, but I didn't copied as it is. I just checked how he has applied logic. So I understood that I have to go in the reverse order. That is the only thing I took from this solution. Other things I didn't check how it is working. So if I plus zeros less than n, so if I plus count of 0 is less than n, ARR of I plus zeros equals to ARR of I. If ARR of I equals to 0, 0 minus equals 1. If I plus, so this is the same condition as this, no. Okay, so here that swapping is happening, and here he is replacing with 0. Here he is creating that extra 0. But the funniest part is why this easy question is so hard. Actually, this logic is very difficult to understand what it happening inside. Yesterday also I tried to go through it, but I failed. So I'll just check Python debugger online. So let's copy this solution and then call that function. Hmm. How I forgot how to run this part of code. Okay, let's create that sol equals to solution. Let's take some array. I will just copy it from this thing. Arr equals to then I will call that function sol dot duplicate zeros and then pass it with arr. Here I need to have that return arr. Let's check how this debugger work. Do I need to go through this guide? Okay. How to add breakpoint? Oh, it got added automatically. Double click. Hmm. So right now I guess it is here. Hmm. I want to see this value. Why? Why it is not letting me see the value? Oh, here. Okay. It is not going inside. I don't understand why. Oh, continue. Hmm. So ARR is this: 0 equals to 4 and n equals to 10. So here I am right now. Okay, I equals to 9. That is correct. In the first step we have seen that initially it is 9 plus zeros. 9 plus 0, count of 0 is 1, 2, 3, 4. 1 plus 4, 9 plus 4, 13 is less than n. It is false. So it will go here. If ARR of I equals to 0, which is also false, then it will go in the next. I was right. Oh, maybe I need to have that breakpoint. Wait, I don't need to put breakpoint here. Okay, leave it. We'll put everywhere. This is false. So this condition will remain false for initial how many? 1, 2, 13. I plus count of 0. 0 is 1, 2, 3, 4. 13. So 13 is less than n. 8, 7, 6, 5, 4. So by default, this will be ignored. The last values 5, 7, 0, and 6 because of due to this condition. Okay, so this condition will ignore for first few iterations, and it will only check if ARR of I is equals to 0. If it is 0, it will just minus 1. I mean, it will remove one number. But in the first iteration it was 6. Second iteration it will go inside. Yeah, it is now making it minus 1. So zeros count will be reduced. So you can see it has become 3 from 4. If I plus zeros is less than n. Okay, here we are putting one more condition. Right now I is 8, but 8 plus 3 is also 11, which is not less than n. I mean, if it is not less than the total length, so there is no need to add one more 0. So again here it will skip. Yeah, you can see it didn't went on 19th step. It has reduced one more number. So the next one is 7. Yeah, I is 7, and the element is also 7. 0, 1, 2, 3, 4, 5, 6, 7. It is not 0, it will go back. Now it has went to 5. It will again skip this thing. Okay, 5 for 5. So 7, this was 6th element. 6 plus 4 is 10, which is equals to length. Okay, now it is equal. So because it is equal, we might need to update it. ARR of I equals to 0. 0, 1, 2, 3, 4, 5. I mean, it is at this point. I plus 0 is equals to 0. So it is now updating to 0. It is swapping here and updating here. We can see this live here, huh? So if we keep eye on this ARR, we can see it changing on live. So first iteration it did nothing, second iteration nothing, third iteration nothing, fourth iteration it, it changed this part to 5. Then on the next iteration it made it 0. Again it made this thing also 0. Then 4, 0, 0. So this is a fully optimized code. It is not it is not creating unnecessary zeros. If it is already 0, it is just keeping it as it is. Yeah. So I might need to go through it once more to fully understand this part. Right now I got the concept, but not understood very well. I mean, if someone tells me to write it again on my own, I won't be able to do that because I didn't get this logic 100%. So yeah. So this was today's problem we have solved. Not actually solved, but copied. I'm just, I guess I will mark the problems which are not properly solved. The first one, this merge sorted array, copy it, put it here. So for that, I haven't discussed the logic on the notepad, but that is fine. That wasn't that much complex. That was easy. So I will utilize as much as space as possible. So this solution I need to write. Oh, sorry, I copied wrong one, I guess. Hmm. So this was the first problem actually. So, as per my understanding, I can't directly jump on solving problems without knowing the sorting algorithms or anything, because I'm not aware about the algorithms. I can write my own logic, but that won't be efficient. Like I did in the this squares of a sorted array. In this problem, I solved the problem, but it was not efficient method to solve the problem. So that doesn't helps. So I guess I need to work more upon the data structure and algorithms, and then come back here and try to solve the problems. Because I thought earlier I thought there will be uh, some kind of theory involved, but I don't see any theory. It is just it has directly jumped into the problems. Even here you can see there is search algorithm I need to have. So without knowing those, I can't solve this. um, I don't know, in the earlier part they've said that if you are beginner you can go through this. In the beginner guides they mentioned that part where to start. You can see. Hmm. So I said that I'm not familiar with one or more of these data structures, array, strings, linked list. So they are recommending to start at the top layers of the explore card track. So in the explore card track, top two layers is arrays 101, and this one is the second layer, I guess. Array, string, hash tables, tags, queue, heap, and binary search. But this is not helping for me. I don't know. So I don't I don't know if I should, how much it costs. Is it below 500? 90 into 90. Not worth it. 8100. Why it is showing in dollars? I can't. I won't actually. I can, but I won't buy it. Okay, I will stop here for today. I don't know when I will come back, because offline I will study data structure and algorithm. Um, from Udemy, I have Udemy access. I can't directly share it live, so I will do that part offline, and then I will come back to solving the problems.